After an impressive 3-year pause for extensive upgrades and maintenance, the world-renowned Large Hadron Collider, LHC, at CERN near Geneva in Switzerland, roared back to life in April 2020. This milestone event signaled the start of an extraordinary scientific endeavor known as Run 3, scheduled to unfold a series of mind-bending experiments that are set to captivate the global audience until 2024. However, CERN has recently made a rather unsettling announcement concerning the activation of the iconic Large Hadron Collider. As we explore the remarkable potential threats this groundbreaking development presents to our existence, we uncover an unparalleled narrative of human curiosity and scientific advancement. From 1998 to 2008, the largest and highest energy particle collider was constructed by CERN in collaboration with over 10,000 scientists, hundreds of universities and laboratories from more than 100 countries. This colossal feat of engineering is situated in a 27-kilometer tunnel that lies approximately 175 meters beneath the France-Switzerland border near Geneva. The inaugural collision in this Hadron Collider was accomplished in 2010 at an energy of 3.5 tera-electron volts per beam. This record-shattering figure was almost quadruple the previous world record. Post-upgrades, it attained an astounding 6.5 tera-electron volts per beam. The Large Hadron Collider consists of 4 crossing points where accelerated particles collide. Each one of these 7 detectors is meticulously designed to observe different phenomena and is strategically positioned around these crossing points. While the collider predominantly collides proton beams, it is also equipped to accelerate beams of heavy ions. Once a year, typically for a month, lead collisions and proton-lead collisions are performed. The core objective of this colossal collider is to provide a platform for physicists to validate the predictions of various particle physics theories. Central to these theories are the measurements of the properties of the elusive Higgs boson and the quest for a vast family of new particles as predicted by supersymmetric theories. The term hadrons refers to subatomic composite particles made of quarks, held together by a strong force. This is somewhat analogous to the way that atoms and molecules are held together by electromagnetic force. The more commonly known hadrons include baryons, such as protons and neutrons. They also encompass mesons like the pion and kaon, first discovered during cosmic ray experiments in the late 1940s and early 1950s. A collider is a type of particle accelerator that allows 2 opposing particle beams to collide. Although the construction of these colliders is a daunting task, they are incredibly potent research tools in the field of particle physics. They achieve significantly higher center of mass energy than fixed target setups. The scientists then scrutinize the byproducts of these collisions, which provide us with evidence and information about the structure of the subatomic world and the laws of nature governing them. Quite a few of these byproducts are only produced by high-energy collisions and decay after exceedingly short periods. This means the only feasible way to study these particles is in such a controlled setting as the LHC. The LHC is contained in a circular tunnel, intentionally set at a depth ranging from 50 to 175 meters underground. This depth variation was deliberately chosen to reduce the amount of tunnel lying under the Jura Mountains, thus avoiding the need for the excavation of a vertical access shaft. The tunnel, measuring 3.8 meters wide, is lined with concrete and was constructed between 1983 and 1988. It was previously used to house the Large Electron-Positron Collider. The construction section of the Large Hadron Collider cost around 7.5 billion euros, making it one of the most expensive scientific instruments ever built. Its construction was greenlighted in 1995 with a budget of 2.6 billion euros, plus another 210 million euros earmarked for experiments. After going operational on September 10, 2008, The initial testing of the LHC was delayed for 14 months when a magnet quench incident caused substantial damage to more than 50 superconducting magnets, their mountings, and the vacuum pipe. Now, let's delve into the operational history of the LHC. The first operational run lasted from 2010 to 2013, which collided two opposing particle beams of either protons up to 4 tera-electron volts or lead nuclei. The first run discoveries included the Higgs boson, numerous composite particles, and the first creation of quark-gluon plasma. Fast forward to 2022, after two extensive shutdowns for upgrades, the LHC was operational again, with a new maximum beam energy of 6.8 TeV. This current round, known as Run 3, is expected to last until 2026. Scientists were left bewildered when, on July 7th, a crack appeared in the magnetic field of Earth. This mysterious crack wasn't ephemeral like a lightning flash. Rather, it remained open for a staggering 14 hours. This enabled intense solar winds to pour through the opening and cause massive geomagnetic storms, resulting in some truly awe-inspiring auroras. This crack was a result of a rare phenomenon called a co-rotating interaction region, CERN, from the Sun. These CERNs are large-scale plasma structures that are generated when fast and slow-moving streams of solar wind interact with each other in the low and middle latitude regions of the heliosphere. This heliosphere is the region surrounding the Sun, encompassing the solar magnetic field and the solar wind. Much like coronal mass ejections, chimeras, these co-rotating interaction regions are projected out from the Sun toward Earth. They can contain shock waves and compressed magnetic fields that cause stormy space weather, manifesting itself as magnificent auroras. While the formation of such a crack is concerning, experts assert that this is a normal occurrence. The magnetic field acts as a shield that protects us from solar storms projected by the Sun. However, these cracks reveal that they can remain open for several hours at a time. Although they can cause problems with satellites, radio communications, and power systems, this particular incident did not result in any radio blackouts or power outages. However, it did treat the residents of Canada and the US to an eye-catching display of northern lights. The LHC hasn't just been studying cracks in Earth's magnetic field. It's also been making groundbreaking discoveries in particle physics. Since March 2021, the MICHIO Collider experiments have discovered approximately 59 new hadrons from the data collected from the first two runs of the collider. The journey of scientific discovery is not a sprint, but a marathon. LHC's Run 3 is the next stage of this marathon, and physicists are expecting it to unveil many surprises, such as the recent crack in the Earth's magnetic field that remained open for several hours. These unexpected outcomes serve as stark reminders of the richness of the universe we inhabit and the lengths we are willing to go to unravel its secrets. The story of the Large Hadron Collider is the story of the relentless human spirit, a testament to our insatiable curiosity and tenacity to challenge the unknown. Thank you for spending your time with us today. If you enjoyed our content and would like to see more, please subscribe. Give us a thumbs up if this video brought value to your day, and don't hesitate to share your thoughts or questions in the comments section below. To continue your journey with us, we've handpicked 2 videos for you. Our latest upload on the left and a recommended video just for you on the right. Your engagement motivates us to keep producing content that you love. We're looking forward to seeing you in our next video. Until then, take care.